Welcome back to another lesson in MCV4U. Today we'll be talking about relationships between the graphs of f, f prime, and f double prime. So here we're given the graph of f of x, and it says to draw the derivative to this curve and justify the graph. Okay, so if we look at this, the first thing to note is that the derivative, so the derivative of a function, represents the slopes of all possible tangent lines. Okay, so again, the derivative of the function represents the slope of all possible tangent lines. And here, if we're given f of x is equal to x squared, here we see that it is going to be opening up. So here we see that it's opening up or positive, which means that here the leading coefficient or in short form, we'll write it as LC, is equal or is positive here. The leading coefficient here is positive. If we look at the end behavior of f of x is equal to x squared, so end behavior, short form, we'll write it as EB. So if we look at the end behavior here, so again, the function opens upwards, which means as x goes to negative infinity, so as x goes to negative infinity, f of x goes to positive infinity. So as we see here, as x goes to negative infinity, so it goes this direction, f of x goes to positive infinity. And here, again, if x goes to positive infinity, f of x will also go to positive infinity. So how we write that is we can write that it goes from quadrant 2 to quadrant 1. So here we can write it goes from quadrant 2 to quadrant 1, or Q2 to Q1. And remember, the quadrants move counterclockwise starting from the top right-hand corner. So that's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, so that would be the given f of x function. So what happens if we're looking at the f prime of x function? So here, let's say we're given f prime of x. That would be equal to 2x. And here we see that our leading coefficient is still positive. So our leading coefficient is still positive. And here, because it's an odd degree function, or degree 1, its end behavior is quadrant 3 to quadrant 1. So quadrant 3 to quadrant 1. So here we'll write the end behavior from quadrant 3 to quadrant 1. Okay, so if we look here at some of these values on this graph. So here, if we draw tangent line right here, so here if we draw a tangent line right here, so let me just make it bigger. So here, if we have a tangent line here, see that again the slope is going to be less than 0, and f prime of x will be less than 0. If we draw another line over here, again, just representing the different tangents at different points of the graph, here we see that, again, the slope is greater than 0, and f prime of x would be also greater than 0. Here at the vertex, here at the vertex, we see that the slope will be equal to 0. This means that f prime of x will be equal to 0. Okay, and something unique here, so f prime of x is equal to 0. So here we can see that f prime of x is equal to 0. If we look at the x-intercept, the x-coordinate of the minimum of the vertex is the x-intercept of the derivative function. Okay, so here we see that our x-coordinate of our vertex would be -1, which gives us our x-intercept as well. So here, if we draw our line and draw it through here. Okay, so let's continue. So here it says, given the graph of f of x, okay, here we're given the graph of f of x, draw the derivative to this curve and justify your answer. Okay, so here we see that the graph is f of x is x cubed, and again, positive x cubed, which means that our leading coefficient is positive. And here we see that in our end behavior, again, it starts in quadrant 3 and then moves to quadrant 1 at the end. Starts in quadrant 3 and moves to quadrant 1. So here our end behavior is quadrant 3 to quadrant 1. Okay, so here we can write, so at a local maximum or minimum, we know that again, f prime of 0, f prime of x is equal to 0. And here, we know that, therefore, the x value will represent the x-intercepts of f prime of x. Okay, so here we have, if we find the derivative of x cubed, we know that here f prime of x will provide us with an x squared function, and we see that that's going to be positive. So here our leading coefficient, again, is positive. And our end behavior here will go from quadrant 2 to quadrant 1. Okay, so if we look at this graph here, so here we have, again, a few. We have an x cubed function. We see that here we know that at local maximum, we know that f prime of x is equal to 0. And then the x value of that local max or min represents the x-intercepts of f prime of x. So here we see that we have point at -1 and 1. And so that x value is -1. So for our f prime of x function, which is going to be an x squared function, we see there that it is going to be at -1 as well. And here we have another point of another local minimum, which is at 0.667 and -1.315. And here we see that, again, the x-intercept for our x squared function will fall on where the x value of the local min of the original function is. And here we can see that. Again, if we draw a couple of slopes here, slopes for the tangent. So here, there's a positive slope here, and then it moves to a negative slope. And then again back to the positive slope. And so here, if we look at our function when we draw it, so we draw our derivative function. Here, we're drawing a parabola. And here we see when we're looking at f our f prime of x function, we see that it increases here. So there's an increase here, increase of f prime of x. There is a decrease here of f prime of x. And then there's another increase of f prime of x here. So here we see again that it is negative where the original function is decreasing and positive where it is increasing. So again, it is negative where the original function is decreasing and positive where it is increasing. Okay, so let's look at this. So below the graphs of f of x and f prime of x, which graph is which? Briefly justify your answer. So we've seen in the first few examples, we know that the f of x function is always a degree higher than the f prime of x function. So here we see that this is a degree 3 function and this is a degree 2 function. So here we see that the one on the right would be our f of x function, and the one on the left, which is our quadratic, would be our f prime of x. So we have a cubic function, and here we have a quadratic function. And so for b, here we see that there's a degree 5 and a degree 4. So here, this would be the f of x function, and this would be the f prime of x function. Okay, so example 2 here, Again, it says below are the graphs of f of x, f prime of x, and f double prime of x, which graph is which, and briefly justify your answer. So again, if we look here, we see that there's a degree 4. So that'd be f double prime of x, or sorry, that'd be f of x. Then we have a degree 3, which would be the f prime of x. And then again, it lowers 1 to a degree 2, which would be f double prime of x. Okay, so let's look at this example 3 here. So it says the function to the right is y is equal to f of x. Okay, sketch the graph of y is equal to f prime of x. Okay, so if we look at this here, let's look at the red line first. Okay, so if we look at the red line, we can find the slope here. So if we find the slope, go, or we can use a graph. So if we go down, so 1, 1, 2, 3, and we go over 1. So here we have our delta y over delta x, which is another way to find slope. So for this red line, again, here we have delta y over delta x. So here we see that would be -3 over 1, which is equal to -3. So our slope here is going to be at -3, which means that our y prime is equal to -3. Okay, so again, we can see here, again, the pattern of the slope. And so the slope is going to be y prime is at -3. So here, if we draw y prime at -3, so 1, 2, 3. And so start here and go to the left. So again, that's y prime is equal to -3. Okay, so we'll look at the blue line now. So here, if we go, this one will go delta y over delta x. So for the blue line, we have delta y over delta x, which is equal to 1 over 1, which is equal to just 1 here. And so here we see that the y prime is just equal to 1. Okay, so at 1, that's where it'll be. And so start at the same point that the y prime is equal to -3 stops at. So start here, open circle, and it'll end here where that green line starts as well. So if we look at the green line, we see here that, again, it's a horizontal line, which means that the slope is going to be equal to 0. So here, m is equal to 0, which means that y prime is equal to 0. And so this last point goes here and continues. Okay, so let's look at this last example here. So it says Sanjay flies a drone off his balcony. The graph below is y is equal to h of t, representing the height of the drone in meters at time t seconds relative to the starting height on the balcony. Determine the sign positive or negative or 0 of h of 3, v of 3, and a of 3. Okay, so again, remember that, again, h of t will represent the height of the drone. So height of the drone time t. Remember, v of t is equal to h prime of t. So the derivative, and here represents velocity, and a of t is equal to v of t or v prime of t, which is also equal to h double prime of t, and that represents, again, the acceleration. Okay, so if we look at this, if we start, we know that, again, wherever the local maximums or local minimums are, that's where the derivative graph will have its x-intercepts. So here, if we draw our f of t function, so it starts here, goes to here, and there's another one here as well. So again, we see that the original function is a power 4 function, and so our next function will be a cubic function. So it goes down, goes up, and then goes back down. And so we see that that would represent b of t, and then to represent a of t, then again we see that wherever there is a local max or a local min, and that's where our quadratic will be. And so here we see that at this point and at this point is where we'll be able to draw our quadratic. Okay. So here, if we look at that, so we kind of worked backwards and we did the graph first. But here, again, we see that at h of 3, again, at h of 3. So that's the original graph. So here, h of 3, that's when, again, times equal to 3. And that will be at -1. And that is below the initial position. Okay, so here h of 3 is equal to -1. Again, the drone is below the initial position or negative height. Here at v of 3, we look at v of 3, we see that v of 3 here, that's at the same point. Again, it's at a local maximum and minimum, which means that here, that would be equal to 0. So here, that means the drone is at rest. Okay, and here, at a of 3, we see that it is increasing. So a of 3 is greater than 0, and that means it's positive. And that means here that the velocity is increasing. But even though the velocity is increasing, it doesn't mean that it's not. Doesn't mean that it is speeding up. Yeah. So again, it does not necessarily mean this speeding up. Again, it depends on the direction of the motion that is occurring.